Imagine standing face to face with a 500-pound predator, teeth like daggers, claws like scythes, armor plating thicker than your entire body. You have no fangs, no armor, no speed. You have a stick, a sharp rock, and a dream to survive. For most of human prehistory, we were not the hunters. We were the prey, being hunted by megafauna like a saber-toothed cat, a cave bear, and many other beasts. But then, everything changed. Not through muscle, not through speed, not through teeth or claws, through liquid death. This is the story of how fragile, soft-skinned primates became the world's most feared killers. And it started with a chemical accident. Let's talk about the problem our ancestors faced. In the Pleistocene, roughly 2.6 million to 11,000 years ago, Earth was home to giants. These weren't your average predators. A saber-toothed cat weighed up to 400 pounds. Cave bears topped 1,500 pounds. And they evolved for one purpose: dominance. Our ancestors? A walking contradiction. Soft skin, no claws, no poison sacs like snakes, no venomous spines like porcupines. Direct confrontation was suicide. Our only edge was something we barely understood: our brains. And our brains worked best when we didn't have to get close to those beasts. So we used our brain to tackle those beasts from distance. For hundreds of thousands of years, our ancestors were foragers. They consumed thousands of plant species, watching carefully which plants nourished and which killed. These weren't random experiments. Observing animals die from plant matter taught them which species were dangerous. But here's where genius met accident. Around 80,000 to 100,000 years ago, across Africa, South America, and Southeast Asia, something shifted in human thinking. A hunter notices something. An animal collapses from a single puncture wound made by a thorn dipped in plant juice. The wound itself is minimal, but the effect is total. Suddenly, size didn't matter. This was the moment, the threshold where our ancestors transformed from scavengers hoping to catch sick animals into apex hunters. They began intentional collection: nightshades, datura, aconitum, ricin-bearing castor beans, tubers containing strychnine-like alkaloids, each discovered through trial and error, and many deaths. The method was brutal: observe, test, die, survive, refine. Now, let's talk chemistry. Because this story only works if we understand how these poisons actually killed. Most plant neurotoxins work on the same principle. They attack the nervous system by disrupting sodium channels in nerve and muscle cells. When ancient humans used these neurotoxins to hunt predators, the toxin enters a predator's bloodstream. It's like throwing wrenches into the machinery of life itself. Sodium can't flow. Signals can't transmit. Muscles begin to fail. First comes trembling, then paralysis, then respiratory collapse. The predator stops breathing. Death was often terrifyingly fast. Now here's the genius part. Our ancestors didn't understand molecular biology, but they observed. They noticed patterns. Through empirical observation, pure experimentation, they identified the most lethal combinations. From plants to insects escalation. But plants were just the beginning. Our ancestors made a second critical discovery. Certain insects and amphibians produce toxins. Those toxins are far more potent than anything in the plant kingdom. The poison dart frog, a creature no larger than your fingernail, contains enough alkaloid poison in its skin to kill 10 humans. Certain beetles produce toxins called cantharidin and other compounds, so devastating that a tiny amount can stop a creature's heart. Our ancestors observed this, and they figured out how to harvest it. This wasn't chemistry as we know it. It was raw biological engineering. They learned to crush beetles, to extract secretions from poisonous frogs, methods that required experimentation and caused casualties. They discovered which insects' toxins were stable enough to survive the journey from extraction to application. The key discovery? Concentration. By boiling plant material over and over, reducing it to its essential compounds, they could create poisons, hundreds of times more lethal than the original plant. A tiny amount, a droplet on a spearhead, could fell a megafauna creature weighing half a ton. The mechanics of precision hunting. This chemical revolution completely restructured how hunting worked. Before poison, you needed to bash the animal to death, repeatedly, with force, which meant getting close, which meant risking your life every single time. After poison, you needed a scratch, a single penetration, a drop of liquid death on the point of a spear. The predator doesn't die of blood loss. It dies because its nervous system is shutting down. Its muscles are failing. Its breath stops. For large megafauna, this might take 10-30 minutes. But here's the psychological shift. The predator is no longer a threat. A cave bear, convulsing and paralyzed, can't hurt you. A saber-tooth whose muscles are locking up can't pounce. A mammoth staggering and collapsing isn't charging. This changes everything. Suddenly, a kid, a woman, an old person can contribute to the hunt. The food chain didn't shift because we got stronger. It shifted because we got smarter. From liquid death to modern medicine. Here's where it gets profound. Everything in modern medicine traces back to this moment. When our ancestors figured out that you could kill selectively, that you could modulate dosage, that you could weaponize a molecule. The difference between poison and medicine is often just the dose. Medieval doctors used poison knowledge to create medicines. Renaissance alchemists studied toxicology to find cure to diseases. Paracelsus, the father of toxicology, literally said, "The dose makes the poison." This principle was born when our ancestors crushed beetles to survive and became the foundation of pharmacology. Today, we use alkaloids and derivatives from ancient poisons to treat cancer, manage pain, regulate heart function, and combat disease. The botulinum toxin, one of the deadliest substances known to humanity, is now used to treat migraines, muscle spasticity, and cosmetic conditions. Strychnine, ricin, curare, aconite, these weren't just weapons, they were teachers. They taught us how the nervous system works, how to manipulate it, how to save lives with the same knowledge we once used to take them. Our ancestors' greatest evolutionary weapon wasn't muscle or intelligence in the abstract sense. It was chemical literacy, the understanding that nature contains hidden weapons and medicines, that observation and experimentation could unlock them, that molecules matter more than might. This single insight, born from desperation in the Pleistocene, cascaded through human history. The final question. When we look at modern civilization, our reliance on pharmaceuticals, on synthetic chemistry, on molecular manipulation, are we transcending our primitive instincts? Or are we simply continuing them? Every time we take a pill, every time we use a pesticide, every time we engineer a molecule to bind to a receptor in our brain. We're doing exactly what our ancestors did in the Pleistocene. We're weaponizing chemistry. Look at CBRN weapons that we created. The question isn't whether we've escaped our past. The question is, will we remember what it taught us? Also, watch our video on CBRN weapons on our channel. Please like, share, support, and subscribe to the channel for more videos. Thanks for watching!